Hey guys, do you want automated mist coolant on your Avid CNC setup for cutting aluminum and other metals? Stick here, I'm going to walk you through the hardware and the software configuration that you need to do to make it all automagical. So why do I want this setup? Well, as I said in my previous videos, I cut a lot of aluminum and plastic. I don't really do woodworking on my Avid CNC. Does that make me an idiot? Maybe. But one thing with aluminum in particular is you really need some sort of coolant and air to keep all the parts and the end mills nice and cool and cutting correctly. It's super important, bro. So I originally wired up my mist system with like this manual valve that you would turn on and off, but I would forget to turn it off. I come back out and I have like mist and coolant everywhere. It was kind of a mess, because I'm just that forgetful. And I knew that, Mach 4 and the Avid setup, they had support for automatic cooling built into the software, and I was hoping the hardware side of things. I went digging around in the documentation, the pins config screen on Mach 4, and I saw that they had already had it set up, like that was already mapped correctly to the M7, M9 commands to certain output relays on the controller. So I was digging around in the Ethernet smooth stepper configuration where all the pins are. Click on output signals there, and I was just kind of scrolling around the other day and I found that mist coolant M7 M9 is already set up for port 2 or pin 216. So I need to find where that is exactly on the diagram, and then that's what we're going to go into. And if everything is good, I just issue an M07 command and an M09 and it should turn it on and off. So let's see if we can do that. So I was like, all right, bro, it's on. Let's go buy some hardware. Affiliate links below. Buy me a new fishing reel. So I got a mist block, which has air input and coolant input in 2 different spots, pneumatic tubes and connectors, a container of your choice filled with the coolant of your choice. In my case right now, I'm using denatured alcohol because Datron uses denatured alcohol, and I figured if it's good enough for them, it's good enough for me. And the nice thing about denatured alcohol is it evaporates off and I don't have a big puddle of mess anywhere. Sweet. A 12-volt air solenoid. If you buy the pneumatic tubes that I have and the solenoid I have, they'll fit together. You need a 5-volt to 12-volt relay. In my case, I got a relay that would support a wide variety of input voltages and output voltages. A 12-volt power supply to provide power to the solenoid. Some 20-gauge 2-conductor wire. I had some left over from my spindle install, but I have a link to some on Amazon. Some wire connectors, a little spade fork kind to fit the relay. And you might want a manifold if you're going to run air from your compressor to other things. You need to split it off, so I have a manifold in the back. It's a manual. You turn it and you close it. That's what we're going to be replacing. So as I mentioned before, I went digging through the Mach 4 pins configuration screens, and I found where they had already set up pin 2-16 to handle coolant, mist coolant in particular, which is the M7 command. and the M9 to turn it off if you're not familiar with that. And it basically, you know, you just plug in your wires into these two inputs correctly, and when you issue the M7 command, the mist will come on. When you issue the M9 command, the mist will go off. Pretty sweet. So let's head to the bench and wire up everything. So I have a 12-volt power supply because my solenoid is 12 volts. And then I have a relay here, so 3 to 32 volts and output up to 220. So we're gonna come out of the ESS pinouts into here, and then out of here into the power supply and the solenoid. Should be pretty straightforward, even though I've never done one of these before. It looks pretty easy. I have my wire snippers, the spade terminals for this connection, and I just got some 18-2 thermostat wire, which I hope will work. I couldn't find the wire that I wanted at the local big box, so I just grabbed this. Not perfect, but you know, I hope it will work. All right, first thing I'm gonna do is wire up this side of the controller that goes to the ESS. Strip those two connectors and go into these spade terminals. All right, do the other one. And then go get a bigger pair of pliers though. All right, there we go. This is going to be my positive. Go down there, and white will be my negative. And then this will run over to the ESS. I'm not really sure where I'm going to place this yet. That probably would have been a good thing to figure out beforehand. But yeah, no. All right, so now I need to come positive to here. So this is the 12-volt power supply with a barrel connector to a wire connector thingy. That's the technical term. Positive is here. We go positive into there. Okay, then I just take this negative and go into one side of the relay. Then I have a negative leg coming off the other side of the relay. And that'll make our connection. Okay, so now I have negative coming out of the solenoid into the positive side of this, or slot 1, and then I'll come out of here into here, the negative side there. And I'm gonna use, I could take some of that double-stranded wire and cut out the middle part, but I'm going to go ahead and use some of this. This is just some 22 gauge strand wire. Then we'll kind of wire it into place on the controller and see if I can actually get it to work before we get everything kind of into its final resting spot and resting stage. All right, so this comes out of here. Negative, and this strand will go into the negative side of this barrel connector. I hope. I am not an electrician or anywhere close to anybody that knows anything about circuits. Just a hacker, bro. All right, got that done, and I'm just gonna peel off like a bunch of wire here to make sure I have enough to go wherever I might want to go to hook this up. I already have a valve on my airline that I've been using manually to do this currently, so I should be able to just take that solenoid, put it right in that spot, and replace the manual valve with solenoid, and we should have automated cooling. That's the plan. Strip these guys down real quick, and then we'll hop over to the controller and figure out where we need to put these. Alrighty, let's go. All right, now that we have everything wired up, on that footage you saw I was using this really weird 2-strand doorbell wire. It worked for testing, but like it was a mess. Get the wire that I got later, it's better. So basically we have everything all wired up. We're left with the solenoid on one end, a leg down to the power supply, and some bare wires hanging out the other end. So the bare wires will go directly into the ESS controller. I'd recommend, running them up through the bottom. They have input port, like pass-throughs, I guess, on the bottom. Run them through there and hook them into the correct pins. Again, you'll see one labeled ground and one is labeled something else. And you'll see up here, they're kind of paired together. I had a really, really hard time getting in there and finding enough space to move and getting them into the right spot. It was kind of a nightmare. I tried to do it while I was filming and it was just even harder. I ended up putting it in the wrong spot like 3 times. So get in there, get a light. If you're an old dude like me, put your glasses on because you're gonna need to figure that out. It's really small and tiny. All right, I'm on the Avid support site here and we see that relay output 216, 5 volts are 19 and 20. 20 is the ground and 19 is the pin. So if we come up here, this is great footage here, by the way. So if we come up here to the actual schematic, we see 19 and 20 here up top, port 2, 19 and 20. So positive will go into 19, negative or ground will go into 20. And after I hook that up, power everything up, we should work. Fingers crossed. All right, come in here. Should be this guy right here, out and ground 2. So this is tight. Let's try to do one at a time here. Put that in the right one. I did not. Why didn't you stop me? Seriously. You guys can see better than I can. That looks like that's good there. Okay, scoop that one up and out of the way. And we'll come in for our ground wire. All right. I promise I'll clean this all up later, bro. Okay, that's wired there. Now I just have everything else here kind of sitting on the floor. So we have the relay, power, and the solenoid. I'm gonna plug the power into my strip right here. That's good. And we should hear that solenoid turn on when we type in M07. Once you get that hooked up, you can take your solenoid valve, and again, I already had a manual valve in place, so I just replaced the manual valve with the solenoid valve. Plug in your power supply, turn everything on, and you should be good to go. Easiest way to test it is turn on your air supply, go to the MDI window, type in M7, cycle MDI start, and your mist should come on. Type M9, cycle MDI starts, and it should go off. All right, here we go, guys. I've typed M7 into the MDI window, and if everything is wired up correctly, if I hit cycle start MDI, it'll start spraying. Cross your fingers. Woo! And to stop it, I'm going to execute an M9 command, hit cycle start, and it should stop. Yeah, boy! That was the worst yeah, boy I've ever heard. If that's all working, good for you. If it's not, you know, like where I messed up was really in the hooking it up to the controller. Again, those are super tiny spots and it's kind of dark in there and really hard to see. So check that first and just check your wiring because it should just work if all your wiring is correct. So now we go run over to the software side to make this all kind of nice and automated. When you're setting up your tool in Fusion 360 CAM, we'll have some tutorials coming soon, I promise. Make sure that you select Mist Coolant. You can set that up in the tool library. You can set it up, ad hoc while you're adding tools. And by doing that, adding Mist Coolant option to that particular tool, it will issue inside the G-code the proper M7 and M9 commands when it deems fit, right? So basically, after it picks up a tool, starts spinning it up, it'll start the coolant. When it spins the tool down, it'll turn the coolant off and make that tool change. Gonna have videos on the tool changer coming up soon too, guys. It's a really, really hard video to make. Bro. All right, so let's see how it all works together. So hey guys, if you have any questions, any comments about my ghetto setup, leave them below. I'll try to answer them as much as I can. Not really a CNC expert, it's the first time I've got one, but hey, I'll try to help you out. And don't forget to hit that subscribe button because we're gonna be running through more and more machine setup here. We have the tool changer setup coming up soon, as well as mold cutting tutorials, aluminum cutting tutorials, all kinds of cool stuff. Take care, tight lines.